Welcome to Vintage Radio Cafe, your #1 channel for relaxing vintage audio restoration. If you like watching an idiot wielding a soldering iron, you've come to the right place. Watch Ray's attempts to fix wonderful forgotten radios from another era, way before transistors. Sometimes he even gets them working again. What could go wrong, right?
Okay, folks, so we're back. It's the next day, late at night. I just finished listening to the hockey game, and we lost. Actually, we got clobbered by the Florida Panthers. We lost 6-1. Really bad game. The goalies were not too hot, to be honest. Anyways, last night I texted Richard about the radio and explained to him what was going on, that I had to change all the vacuum tubes, and probably a full recap was needed. So I explained to him what would be the cost and all that, and he said, no problem, go ahead with it. So I ordered the vacuum tubes and told him how much it was going to cost, told him I was in a hurry. He could pay me later when I give him back the radio, but nope. Got up this morning and he had already transferred the money in my bank account. So I really, really appreciate it, because it's, it gets to be quite expensive. So there's, in my opinion, there's no better way to learn about a radio than to really start identifying all the parts with the schematics, so you know what is where and what the values should be. So I decided I was going to start with what I already know is a problematic section. And here you have two output valves, one EL84, one ECL82, and it was completely dead. I marked it. So why was it dead? That's what I wanted to know. So I remove those caps because they're paralleled with resistors, both of them, so I can get a clear reading unless I untwisted the resistors. They go underneath, neatly tucked in. Quite a bit of a hassle to remove them, but my point is, on the ECL82, those are a pair of anode bypass caps. And on the ECL82 side, sure enough, the resistor is completely blown. It's open. I'll try to show you a little bit closer. Yeah, no kidding. Look how black it is in the middle. So no reading there. It's open. It's kaput. And the let's have a look at its capacitor. Should be a 25 microfarad, and it's also Cactus at 3.8 something microfarad. So that was the issue. On the other side, the EL84, the resistor should be at 250 ohms, and it's at 249.2, so it's perfect. I'm not going to touch it. This capacitor should be at 50, and I believe it's not even 30. Let's have a look at that. If I can connect it. And the positive here. What do we get? Yeah, 29, not even 30. So this is a goner as well. So what's interesting is to try to understand what was going on. Why did it fail? on this side? Well, again, I asked David for some help, and the guy, he really impresses me all the time. He knew more about the radio after looking at the schematics for 5 minutes than I did after working 3 days on it. Basically, as you can see here, the output is split in two, EL84, ECL82. The ECL82 comes into function with the EL84 only when the stereo mode is activated, which in this case means only when you use the pickup or the external recorder. Yeah, tape recorder or pickup, that's when this radio becomes stereo. So there's 3 speakers. The 2 smaller ones, I told you this before, are connected together, and the big woofer is alone. So there's 2 output transformer, there's 2 output valves, and this is the design. This is how it's supposed to work. And yeah, let me move in closer again, try to show you what I believe is going to be the source of the problem to begin with. Not sure you're going to be able to see this, but yeah, there's another point 0.01 here, and it's a shielded cap, okay? This is one of the coupling capacitors. The other one I think is going to be underneath. There's a contact strip there. There's 1 or 2 more. So I believe this is the one that failed first, and it let the DC go through, which in turn overheated the capacitor, the resistor, and the grid of the ECL82. Yeah, that's the way I understand it. Pretty sure that's the working principle of this radio. So tomorrow I'm going to continue identifying all the parts and order what I don't have on hand, because I don't think I have 0.15 like this one anymore. 0.25, 25 microfarads, I don't believe we can get them anymore, so I'll have to find something close, and I'll order everything, and with any luck I'll be able to start the recapping before the weekend. Yeah, Friday or Saturday probably. I just wanted to show you that. I think it's a very interesting design, well worth repairing, that's for sure. That's for sure. Yeah. So the other half of the output and the other set of speakers only come into play when you activate the pickup. Yeah. Great idea. So I'm off to bed. I'll start working on it tomorrow morning. Have a good night, guys. Talk again when I come back. Okay, folks, so we're back. And yeah, as you can see, the chassis is now in my old chassis holder because I didn't get the new one done already. And what I've done is, yeah, finished identifying all the components, every single one of them on the chassis. There's a few here on the side, and all the ones at the bottom. So I made my list, my usual list. All the vacuum tubes I'm still waiting for. They are in Miami right now. The electrolytics, okay, which they're all identified, and the ones I had in stock I marked. The other ones, I mean, on order, they're marked. I decided I was going to change both resistors, although the 251 was still good. Yeah, I'm not going to take any chances. It doesn't look too hot. Seems to have heated up a bit. So yeah, it's a few cents. So I'm going to change it as well, since I'll already be in that area. All the paper caps are here. I've marked the first ones that are on top, the ones that are on the bottom. There's one shielded one. I think there's actually two. I only saw one. As I go along, I might find the other one. So one is shielded. It's the one that I believe is at fault. Yeah, going to the output valves. Yeah. And I got my order from DG So everything I need is here. The electrolytics for the main filter can. I have several. I ordered more 47s from a different brand just to see if they're going to be a little bit higher than the ones I usually get, which yeah, barely make it to 44 microfarads, between 42 and 44. What do we have here? Yeah, so the resistors are here, the other electrolytics, and all the rest of the paper caps are going to be replaced with film caps. I've got a different format, so I'll see, according to, you know, depending on the room I have to work, I'll decide which one I'm going to use. Bigger, smaller, axial, through holes, whatever is more convenient and safest. I also got the computer running with the schematic so I can mark everything I do as I go along. My old trusty mid-2011 Mac. That's about all it's good to do these days. Can't upgrade it. It's been years since I was able to upgrade it to anything. Also, I got my flashlight charging and my trusty magnifying glasses are almost charged up completely. And last but not least, I already prayed St. Jude, the saint of desperate causes. Yeah, I always do that. And I thank him for everything. He's always got my back. So, let's get to it. I'll get back whether when I'm finished or midway, or if I find something interesting. So catch you later, guys. So okay guys, welcome back. It's been 2 days since I started recapping the Telefunken Sonata. As you can see, not as many components left here to be installed. All those have been done. And you can see on the chassis the difference. All the new caps in. Try to go on this side. Have a better view. Yeah. And a couple on the side. All yellow ones. There was one here. Yeah, C58 that was shielded. That was quite a job to do. The two electrolytics here, C77, C79. They're also a bitch to install and to take the other ones out. Those two that are still left with green stickers, they're underneath. I marked them as no reach. There's no way I can do it. No, no way. I can't move this plate because all the wires soldered to the both sockets for the valves. All the wires are so short. I have no room, even if I can get the metal plate loose. Yeah, I would have to unsolder like, I don't know, 10, 15 wires, which I cannot see. Can't see what I'm doing. So yeah, a 150 puff and a 3300 puff that will remain there. just to give you an idea, I'm about halfway done, and got 15 replaced with those two I just mentioned, two electrolytics. So they are here, and yeah, I've shown you this before. Almost below 30 microfarads, and this one that should be a 25 is at 3.8. So that's about all I've done on the electrolytic side. Now on the top, all those you've seen in the tray are here. They've all been replaced. The two I mentioned, not reachable. And just look at the values. I mean, yeah, this should have been a 0.01, was a 0.02, 0.01, 0.0188. So almost, double the value. This one, 30% higher, 33 puff. What is it, 46, 40 puff. This one, more than 3 times its value, 3 times its value. This one higher as well. Only this one was lower, at 0.047, at 0.022, and so on and so forth. Those two, yeah, the C76 at 1,000 puff, one is at 1830, the other one's at 1900. So you get the point, right? That's why we replaced them all. After a couple of them, you got a pretty good sample of what the capacitors are going to be like in the chassis. What I've done, as usual, I marked with a green dot everything that's been replaced. So all the yellow ones are the regular paper cap. The orange ones are the coupling caps. So a couple of them are done. I'm sorry. The other ones are going to be at the bottom. This one I still don't know where it is exactly. I know it's connected to the ABC 80, but underneath, so much stuff, I can't see it. This guy is also at the bottom, but I can see it. It's going to be hard to reach, but I should be able to manage. So today the plan will be to do the main filter can, remove it if we can. If I don't break any tabs, restuff it, and after that, I'll also gut the rectifier and start replacing it. At least make a board so I can test it when I get the all the vacuum tubes. They are presently in transit, meaning they left the USA, and they're somewhere, I don't know, either in a plane or in the facility here in Canada, but they're not in the US anymore. So, as for the main filter can, well, I already removed the rectifier because it's going to give me more room to work underneath. So it was here, like that. So I took pictures, I marked everything, so I got a pretty good idea where everything goes. Also took pictures of underneath this guy to see where everything is connected. So there's two capacitors there. So there's two red wires plus a white one on one of the capacitors. Then the can is grounded, and the negative is also underneath there. So there's a couple of wires to undo. The most difficult part, most tedious part, is not to break the tab so I can reuse the can. So yeah, I said I would come back when I found something interesting. Not really anything interesting, but I'm halfway done. So just to let you know how I'm doing. And yeah, when the valves come in, hopefully the recapping will be all done. So I can start do proper testing and check all the lines here for the B+, all the pathways for B+, and maybe I'll find a few resistors that are gone. We'll see. So that's the plan for today. Remove, restuff the can, and have everything ready so I can finish doing the bottom part. On the bottom side, I thought there were maybe 8 or 9, but already I'm up to 11 caps. There are 2 more that I couldn't see underneath here. Once I flip the chassis upside down, I can see them. Hopefully I'll be able to reach them, because they go on the volume pot, or the tone control here. So yeah, it would be important to replace them, but not at the risk of burning something close, or not being able to resolder them safely. So I had to evaluate as I go along. Yeah, be right back when this is done. Or perhaps I'll show you again, the process of restuffing the can. I've shown it so many times already. It's going to be redundant for you guys, for many of you guys, but yeah, we'll see. Catch you later. Okay, folks, so welcome back. It's been a couple of days since I worked on the recapping, the bottom part. Yeah, I was delayed, because of all the Christmas parties I had to go to, and I was hosting my kids on the 24th, Christmas Eve, then had a party on the 25th, and so on and so forth. And yeah, it was, I told you this before, it was a real pain in the neck to recap this one, simply because compared to the other chassis I've worked on for German radios, this one is rather small. Small, but it has just as many components. I think I'm up to 26, 27 caps. There's two that I couldn't reach, that I left there. There's still one here inside the detector, the EABC 80. There's a, I don't know, I think it's a 204 UF electrolytic. I might attempt to remove the can and replace it, but I'll do some tests first. Oh yeah, this is what I've got so far. Still got to do the one on the speaker, the bipolar, but yeah, you get the idea. And C36, I don't know if you'll be able to see it. Yeah, it's hidden somewhere here. C36 was the other shielded cap, and there was a other electrolytic here. I think it was a 4, and so on and so forth. This guy here was so deep inside, it was actually leaning against this wall. So I did what I could. I had to add a piece of a little length of wire here, so I had room to work. I couldn't make a clean joint, so I had to make this joint here. It's soldered, but I also put one of those narets here on it, just to be sure it never makes contacts on any metallic part. So yeah, as usual, those guys are very hard to work on, because all those tiny wires, you don't want to hit those with the soldering iron, because they're going to break instantly. Yeah. One other issue that I had, but that this radio had, was the pilot plant. Yeah, the lamp here. Yeah, let me show you maybe a little bit closer if I can. The way it was installed. it was pretty flimsy. Okay, maybe you can see it here. This was the bulb. This is its socket. So it's just a metal socket. This goes inside like that. And the whole assembly was inside this shroud. The shroud was like this, meaning most of the lamp was covered with this shroud. Actually, I went about this deep. But the problem was, well, this was completely, had no more integrity. Could have maybe glued it, but it would never have been a solid installation fix. So this here, the way it works, well, the center part is just riveted in. And at the bottom, so here, there's a piece of cardboard and the rivet was going through it, but there was actually another layer. And then the spring had to go inside of this. Not even sure I can do it. Well, this was where it was supposed to go. Can't even put it back in. Yeah. So this is how it was. Problem is the rivet has just popped out because those two pieces of cardboard just got thicker. They swell. Yeah, they're all swollen up, so they popped out of the rivet. I don't have that kind of rivet. I'm not even sure if I had the right size or the right tool, the right gun to do it. I could insert it inside of the sleeve here to hold it. So what I did instead, so this is what I came up with. Again, I used some spare parts on the from the Tannhauser, and their system is way better, the Normandy Tannhauser. It was a plastic sleeve like that. So I decided I was not going to use the same shroud, but rather just use this. Okay. And well, it wasn't a problem, but it's just the way it's made. They had those plastic feet here. It was like a T shape. And what I did, my first attempt was to cut it completely and just grind it down with the Dremel. And yeah, I was going to insert it like that. But it was just a little bit too loose. So here is where it was fitted originally with this shroud going that way inside of it, really deep. And since it was all broken up, what I did is use one of my grommets. Problem is, it's a round hole, but there's two metal plates at the bottom. So the hole has two flats there. So the grommet didn't fit perfectly. As you can see, it's sort of D-shaped because of the two flats here, but it still holds in, pretty tight. So I reinserted this little guy in here, but I kept part of the foot there that I had shaved off here. I kept a little bit of it, a little more. I only remove like this much on each side, So that was enough to keep it snug inside. And I put a bit of a hot glue. It might not look good, but I'm telling you, it's very, very sturdy. It's not going anywhere. And why did I use hot glue? Well, it's because there's no way of removing this without taking the whole cabinet, the whole chassis out of the cabinet. So if I ever have, or Richard ever has to replace it, well, you can just remove this, with a pair of pliers or tweezers and remove the socket and replace it, because in the front there's the vellum paper, and there's no access here. There's a wall there. So that's why I decided to go like that. And as you can see here, there are traces of tape. It wasn't there when I took the chassis out of the cabinet, but you can tell there was a piece of tape there to hold it together. Because even if you tried turning it, and that's probably what caused the damage here. If you try to unscrew the bulb, this whole thing moved, and that's where it sliced through the rubber. So that won't happen again. It'll be a little bit tedious to replace it, but I put a brand new one. This one was dead. Put a brand new one inside, so it should last for a long time, hopefully. And of course, I can't find any 7 volts anymore. The closest I could get maybe 2 years ago were 6.8, but even those I can't get anymore, so I had to settle for 6.3 volts. And I don't know. They're probably not going to be the right brightness because the circuit is expecting 7 volts, so it's going to be a 6.3. So I'm guessing it's going to be a little bit brighter, but hey, we'll see. And yeah, so let me turn the whole chassis around, and I'll show you what's the plan for today. So as I was saying, the plan for today, now that the electrolytic filter have been replaced, and I don't know if you can see this, but I marked them as 2 times 56 UF instead of 47s. I'm going to try them because my choice was to use 47s that tested at 42, 43, or 56. So my choice was, either use capacitors at 16% too low value, or use two ones that would be 12% over. So I decided for the latter. We'll see what it does. And today, it's really working on the rectifier, which was here. Yeah, like that. And before I gut it and restuff it, well, I got a test. I got a test with one of Manuel's boards. So it's already assembled. You've got your silicone diodes, and I've got just a piece of wire here to close the circuit. So we'll test it with that, measure the voltage, and if I have to adjust it, then there's 3 slots where I can put resistors in parallel. So that's what I got to do. That's the plan, at least. Yeah. So got a brand new positive wire coming here. This is the same negative or ground. And the problem is always those AC, high power AC, the wires are so small, so flimsy. When I tried to remove it, this one broke off. There's only a little part left. So if I try to remove the insulation to have a little more wire, well, it's probably going to break off again. That's always a problem. Breaks, and you end up, you don't have any more fresh wire to work with. But as usual, I'll find a way. So yeah, I'll get back to you when I'm ready to test the radio with the new rectifier in. Yeah, be right back, guys. Okay, guys, so I installed the temporary rectifier, but before I start doing any tests, I had to change this little bipolar 25 microfarad cap, and I just wanted to show you the old one. It's supposed to be a 25 microfarad. Have a look at this. Come on. You know, more than double the value, almost 2.5 times the value. So it absolutely had to go, and it's gone. And yeah, I'm just gonna finish working on that because the glue is drying. Let me show you this. Yeah, see this connector here? It was just a phenolic plate, and it was broken off right here, and so this one was just dangling. Originally, this phenolic plate was just glued to the backboard, to the speaker board, and I believe when it was soldered, it just broke the phenolic plate. It was glued like that to the backboard, but yeah, with time the glue dried up and it was just dangling. So I put another piece of plastic to hold both parts together, and I glued it down, and I'm going to glue this part with hot glue this time. So if I ever have to remove it, if somebody else has to remove it, hot glue is not permanent, but it's still sturdy enough to hold this. There's practically no pressure. So yeah, let me do this and we'll get back when we're ready to start testing.